Okay, so welcome to today's tutorial. So I guess this is the last lecture I will talk about something for this subject. So today I'm going to have a review of this subject and also to highlight those important points that possibly will be occurring in the examination. Only possibly, not 100% because of course I cannot directly tell you which part will be as which part not. I can only roughly tell you so. So let's firstly going through with the outline of this subject. So we have 9 chapters. So different chapters has different contents. And I think I have made sure that the examination will include something within these 9 chapters. So no chapter will be missed. We at least contain some of them of each chapter. So the first one is related to the introduction of the avionics systems. So if you remember in our first lecture, we talked about lots of histories and all those stuff. Next part is not that much important. Those are just kind of for your understandings of the history. But the most important part is those regulations. And unfortunately, because we are avionics systems related to aviation, we still have to remember something during the test. So this part is that you need to remember. So this is and oh, by the way, this outline I will also upload into the Blackboard, so you can take a reference of it. But just for the outlines and those bullet points. And for the first of all is the understanding of the roles and the regulations and the advisory organizations. This part is very important for every aviation students because you learn aviations. Those regulations are very important, of course, also for our avionics systems. And this, of course, we have different parts. For example, ICAO, FAA. You need to know that ICAO, the ANNEX 10 is related to us, and you need to know what is ANNEX 10 is referring. And FAA, what is FAA, and what is related to us. For example, CFR 14. And NTSB, what is this means and what do they do? And also for FCC and for corresponding regulation related to CFR 47, this is related to us. This part is what we need to remember. And further is RTCA, which committee it is, what it is, and what's the documentations related to them. For example, the DO and MOPS and TSO. And after that, we'll also have some other things that related to like AIM is kind of like a standard. We also need to remember something about that. And by the way, we also need to remember those authorities that also plays the same role, similar role that in the Europe side, which EASA, Eurocare, and Eurocontrol, and so on. And besides, we will in this lecture we also mention about the understanding and architecture and also benefits of the next gen. So next gen is related to the future things related to our avionics systems, and most important is the improvement, how it improve our aviation industry. So this is also very important for you to remember something related to this. So this is chapter 1. So this part is unfortunately is a lot of things that you need to remember. And also for information, our examination is closed book. So for this one, you need to remember this. And okay, let's go to the chapter 2. So in chapter 2, we basically discuss something related to the basic aerodynamics and flight control principles. So some fundamentals like the airfoil and its principle, you need to roughly know what it is, and the calculation of the lift force and the importance of the T-based primary indicators. That's the things that related to, I would say is in our examination, we need you to understand it more related, those things that related to our avionics systems. For example, if you have any like instruments and display something, indicators, you need to know what the indicator is showing to us and how it relates to those fundamentals of aerodynamics. That's the idea we need to test. And we are not going to test you like theoretically how the airfoil is going to generate some lift and those are very aerodynamic things. That's no, yeah, because we are more focused on avionics. And let's how about I think with so for the importance of the T-based primary indicator, we remember that this one is actually related to the this envelope, right? This envelope is related to our airspeed indicator. You have different colors on different sections, and whether that part is going into a failure that is not permitted during our operation, and which one is the operating range, and in which range we are going to be in occasion. And that's the basic idea. You need to remember how it works and how it helps our pilots to have the flights. And then after that, we will also learn something related to the aircraft stability. If you remember that I carry an aircraft model to demonstrate you how it maintains the stability. So this is the diagram we showed during the lecture, is how the stability is going to be achieved. For example, you need to know how this one is going to work, and the pitching moment is very important in this to control this stability. For example, your center of gravity and the center of lift force, they have some kind of relationship, then you can maintain the stability. And for this diagram, how it works, for example, why this red line is going to show you it is statically stable. Why it is this, and what is this steady state means? And that's also the principle you need to understand how it works. This is for the stability. And after that, we'll also go into this, talk about, in this lecture, we talk about some aircraft dynamics and also related to its controls. So of course, when you're talking about controls, you need to know the input and output of our system. For example, in our lecture, we demonstrate this kind of flow chart, looking like this. Oh, this one. For example, our input is some control services, the movement, and then we'll go into our different equations. And based on that, we will have outputs like the actions on our displacements, velocity change, and rotations, altitude change, etc. And this is input and output, and you need to know their relationships. But for the very detailed, like the dynamics, for example, how a specific control surface movement and the corresponding output on the attitude, we may not going to test this because this is too like aerodynamics and those stuff is not related to us. And then we also need to know the importance of aircraft dynamics to our flight control systems. And yeah, for example, one of the very good example is how you use the flight control system and then you design the system to mitigate, we call it Dutch roll. So yeah. And this one is going to be like this kind of, for example, we put a damper and then we're going to mitigate this kind of effects. And yeah, so this is kind of like an example of it. Yeah, but also I want to highlight that we're also not going to test those very like hardcore control equations and those control systems, those logics, those things. The logic maybe tested, but the detailed equations we are not going to, and the deviations we're not going to be put in the examination. And then we're going into chapter 3. So for the chapter 3, we're going to talk about the flight control system. And most important is the 6th indicator to flight control systems. And yeah, Dutch roll we talked about it before, and yaw damper. As is before. And then we're going to talk about some fly-by-wire system, FBW. This one is very important for us because this is some foundations of redoing avionics systems. So you know that what is fly-by-wire? and also some of the components related to it. For example, like the full authority, stability, argumentation, and safety and integrity related to it. Talking about the safety and integrity, if you remember that we mentioned about those redundant systems, for example, this one, we have parallel systems to make our overall system to be reliable enough. So that's this one, like we have the quadruplex redundancy, and we also have triplex redundancy. So if you look at these figures, they actually have a very different, a bit different design. So that's, for example, like this one, the first one we have water, but the last one we have comparator instead of water. So why is that and how it works? You also need to understand it and able to explain why it is. So that's kind of like the idea. And after that, we have the data, digital data implementation. We have input and output for the by-by-by system and control systems. Yeah. And after that, we also talk about autopilot. So for the autopilot, you need to know, we talk about the input, output for the control system and some human factors related to it, and also the functions of autopilot, how it's going to help us pilots to relieve their works. And of course, for the autopilot system, we also have some diagrams introduced in our class, like for example, the panel looks like this, and what is included inside of our autopilot system. For example, we are able to change the heading, input our heading, and then make our autopilot system to make the manual, and also the altitude. And I for sure that each one of you have experience on flight simulator, right? So you have a very good understanding of how autopilot works. And of course, it has parallel systems, have redundancies to ensure the safety and reliability. So that's it. And after that, we also roughly talk about the flight management system. This is related to input and output. You need to also remember the input and output of this one and how it works. Maybe larger this one, and the role of this inside of system. And we have two separate systems, and we have the C, A, B, C. We have three. Yeah, look like this. And of course, the function of the FMS, you need to remember how it helps us. So in the end, what we need to have is looking like this. We need to remember a whole diagram of the role of each systems, looking like this. So this one is very important for you. Let me put it into the main, this one. So this one. So you have the whole flow chart of the diagram and looking like this. So this one shows how each system is combined in our actual aircraft and during the flight, how it helps us. For example, you need to know different components. For example, the whole flow chart from airline to pilot and how it's going to flight management system, autopilot system, fly-by-wire, and flight mechanics. And then we have integration, and we finally have some parameters of our aircraft. And the flow chart is looking like this. And you need to know what is going to be feedback to different parts of the system, subsystems. And for example, you use the air data and sensor is feedback to our autopilot in here, into this location between flight management system and feed into autopilot. And for the AHAS, it's also using the same way instead of other locations. And how GPS and VORDME is going to work into this system. And for example, you need to know that fly-by-wire system is more inside of this loop. Is located more on the inner loop of this flowchart. And autopilot is a bit outer, and flight management system is even outer. And then then the upper layer is the pilot and also our airline and sort of stuff. And besides, you also need to know the let's say the function of different parts. For example, pilot, they have designed waypoints and they're going to input destinations and more other informations. For the autopilot, it will needs to input the design speed, head height, and heading. And for the fly-by-wire system, it is going to input design pitch, yaw, and roll angles, etc. So you need to know the whole flow chart of this. And of course, you need to know the role of different parts, and you need to remember it. And let's go into this part will be end. So chapter 3. To summary, the chapter 3 is more important on the flow chart of this one. If you're going to, or what you need to do is that you're going through with this flow chart and you know each part of inside of this architecture, and then you know the role of different avionics systems in our lecture. Yes, and then we're going into chapter 4. So chapter 4 is the most, if you remember, is the most part that related to calculation. So actually, in this review, I talk about is the whole things in our subject. So not necessary that all of them will be tested in the examination, but our examination will very likely to be some of the information in here. And I will also and something that highlight that is not going to be tested in the exam, that is for sure not going to be tested. And for the chapter 4 is related to the calculation. And if you remember, we have 6 parameters that are able to be calculated based on 3 informations like the static pressure, the total pressure, and the total temperature. And here is like a sort of the importance of different air data. And during these lectures, you'll know which those air data, what that means, and why they are important, and how it's going to be derived. But in our examination, we are not going to ask you to directly derive those equations. That's no, because equations you can find everywhere. So what in our examination is to test how you can apply those equations. So, and also to understand the importance and the meanings of those variables you need to calculate. So for example, the importance of the air data is like you understand how the different indicators like altitude, altimeter, airspeed indicator, vertical speed indicator, they actually calculate how they are calculated from. And yeah, if you let me show the sequence. So in our lecture, we actually, and also in our many of the tutorial, we talk about how to calculate it indirectly. If you forgot how to do so, you can go back and review in our tutorial lectures. I believe they have records. So the sequence is looking like this. So 1, 2, 3, 4, 5, 6, 7. You follow this sequence. You can base on those 3 parameters. PS, PT, and the total temperature to calculate all 7 informations. And the vertical speed is actually related to difference of the pressure on different times. So not within this 3. And for sure, you will know that in our tutorial, I also talk about that. And yes, so later I will show you what information will be provided in our examination so that you can have some preparations. And yeah. So after that, in the meantime, besides those sensors, those 7 parameters, we also talk about the sensor error and also the safety. So this one is also very important because no matter which sensor you are using, they are actually not a perfect sensor. They will naturally include some kind of noise, some kind of error, and then you need to use your engineering thinking and mindset to judge whether the sensor is safety for your usage or is not safety for your usage. I think this is actually very practical use. For example, in your future, maybe you're going to FYP final year project, you may need to select your own sensors. Then you need to use your engineering knowledge to select those sensors. And what you did is to ensure the specification of the sensor meets your requirement. So that is very important. in our lecture, we discussed a case showcase is that two aircraft is flying together and in the opposite direction. And if you're using the pressure sensor to measure the height, if it contains some kind of error, then your height measurement will have some kind of error, of course. And if the error is too much, then these two aircraft may not be safely have those height separation, may not enough, or you may wrongly have for example, like the upper one may have a noise that have a variation up and down that very close to the lower one, so that there are high possibility to have a crash. So that is not safety, and then you need to based on the parameters of the sensor, for example, the uncertainty of the sensor, to judge whether this sensor is safe or not safe. And then you need to know how to calculate the requirement for the sensor. For example, how much noise is acceptable for our sensors. And after that, we'll also, of course, those indicators, you need to understand how it works. For example, the needles, what does the needle means? And like, for example, here, the color, what does the color means? And here, the positive one is on the upper part, and the negative one is on the lower parts, and sort of stuff. And you need to know how to read those indicators. That's also one of the things you learn in our lecture. And this part is for the chapter 4. And for the chapter 5, we are going through with the inertial sensors and navigation systems. And in here, we mainly talk about the gyroscope. So for this chapter, I just find out that the compass one is not being recorded because I forgot to record, but never mind. So because the compass one, I will not going into our examination, and we are more focused on the gyro one because the gyro is more related to now our current cutting-edge technology. And this one is more important, but you need to remember there has two types of gyro. One is the direction gyro, another is brake gyro, and they use very different principles to work. And for example, one is use rigidity, the other is use precision. And I think I made this one. It's the wrong. They need to be matched correspondingly in order to avoid some misunderstanding. Yes, yes, this is correct. And for example, if you look at the direction gyro, and this one can able to provide you the artificial horizon, the directional gyro indicator, for example, like this. You know the first one, you know the attitude, for example, the pitching angle, and also the roll angle. And after that, the other one is going to tell you the heading of the aircraft, and you need to know how it works and why it able to tell you that kind of information. And the last one is this one. Is that related to rate gyro? It make use of the precision, and then to measure the rates. And for this one, you need to know how it works and why it works. And I think I will not going to include some of the calculations related to this brake gyro because this one is sometimes hard to calculate. But you need to know you need to know how it works in terms of principle. So after that, let me see. So we also introduced the optic gyroscope, and for example, using RLG, the laser one, and the fiber one. And these two is most advanced one, and you need to know how it works and why it is better. And after that, we'll also talk about the attitude derivations. And this one, for our inertial sensors, will based on two kinds. There are two kinds of the inertial sensors. One is based on gimbal. The other one is a straight down system. You need to know the difference of these two, and the benefits, the pros and cons of these two, and you need to remember them. And after that, we'll talk about the quaternion. And for the quaternions, that what you being taught is to calculate the attitudes of your aircraft. So this one is actually to calculate the attitude is kind of like a very complicated method, very complicated approach, have different kinds of methods to do so. So please stick on the what we have taught in our class, because in our let me say an example is that if you're going to do a rotation of the axis, you can firstly rotate x-axis and y-axis and z-axis, and you can use other methods. But please follow the methods in our lecture so that we can easy to know that you understand the main idea. Yeah. And in here, we also based on you need to know why we're using quaternions and the benefits of using so, and also know how to let's say how to technically calculate each parameters of the attitude change by using those quaternions and also those roll pitch, roll angle. So, but we in our lecture we have an example that we give you the roll pitch rate and also the attitude in terms of quaternion, and then you can base on those parameters to calculate what's going to be happened in the following next second and the consequence of like some, for example, how it looks like, how this movement looks like. For example, it's going to be pitching up or going to be pitching down, and that one you can judge by the attitude of the aircraft. And after that, we also talk about the attitude heading reference system, what we call is AHRS. So this one is also very common in avionics systems. You need to know the principles of it, why it called like this, and how it works, and how the architecture looks like, and etc. And after that, we talk about the inertial navigation systems, and especially related to the deck reckoning. So the idea is that for the inertial navigation system, what you measure is that the relative displacement and the attitude movement between 2 seconds or 2 epochs, what we call. And for this one, what you do for the navigation is based on deck reckoning, is that you base on a location, and then you know the relative displacement, and then you know the next location, and then you base the relative position at next epoch again, and keep, we call propagating the location of our aircraft, and then you know the location of our aircraft at each second, each epoch. And of course, we roughly talk about the sensor integration, and you need to know the pros and cons of using sensor integration, how the sensor integration can improve our locations information. For example, for our INETs, we usually integrate with GPS or GNSS, and this integration is going to be able to compensate some of the drift of our INETs. This is kind of like an example of it. And for chapter 6, before chapter 6, the before 5 chapters is more related to those like aerodynamic stuff and those movements and more dynamic. And starting from the chapter 6 is more related to the electronic stuff. And starting from here, we learn about airborne communications. And so the first one is that related to the EM wave propagation. So in this lecture, you need to know the fundamentals of our signals. For example, the frequency, amplitude, and also the phase. And then you need to know why they are important and how this one what their effects on our signal. This is the fundamentals and also other very basic parameters. And also the type of our propagation and the properties. Here the type means it's more related to our avionics systems, like this one, because you can classify different types on different applications. But for our avionics systems and aircraft aviations, they are more related to non-ionospheric and ionospheric one, because one is related to the sky wave. We have the reflections from the ionosphere, and the other one is the non-ionospheric, which means the surface wave. It's almost attached to the surface and then for the propagation. And the criteria of separating these two kinds of wave and their characteristics. For example, sky wave is a reflection, is a bit longer, the communication range is a bit longer than the surface wave. But in between, there will have a gap. It's a dead zone that do not have any signals available. And besides, we have the space wave. And space wave is, the space wave means that that is below the ionospheric, they have direct propagation. And on the other hand, we have the satellite communication, which is also related to the ionospheric, but the signal from the satellite directly propagates, penetrate the ionospheric, and then being received by us. And here, and also you need to understand how to separate this one and how to classify this one, these few different kinds of propagations. And after that, we talk about antennas. For example, we talk about the halfway dipole antenna, and you roughly know how it works, and also the quarter wave antenna, and you need to know compared to the half-wave dipole why it is better, and also how it works, why we are able to use this kind of geometry to make it to be only a quarter wave is okay. And after that, we talk about the modulation of the signal. This one is also very important. For example, we actually have 4 types of modulation, but the key we are more focused on these 3 is amplitude, frequency, and phase modulation, and how it looks like. And be remember that, for example, amplitude is during the modulation, the amplitude is going to be changed. And for the frequency modulation, your information is modulated by signal, but the signals is going to have different frequency on different sections. And that difference is going to show you some of the information related to us. And the other one is related to the phase modulation. And if you have some information, you can indicate this information by shifting the phase. And that's for this. And after that, we will also talk about the power link. So this one also involves some of the calculation, if you remember our assignment 2. So for this one, you calculated the power related to dB. So in our calculation, especially in our tutorial 2, if you go back into the video, you can find out you have a lot of, like a big list of a lot of calculations on different dB, and the input power, for example, is in dB. You are able to calculate the corresponding power in dBm, in which the reference is in 1 milliwatts, so and so on. So this is related to the logarithm. And after that, we will also have the link budget. So what link budget means is that, let me have do we have an demonstration? No. We have one? No. So the link budget, what it means is that we have a source of the signal. We also have a receiver of the signal. We need to make sure the source is enough strong so that our receiver side is able to receive something. So for example, if our source is not enough strong, the signal is a bit weak. So even though in our source we have some amplifier to amplify signal, but our power during the propagation, we have the loss during the pass. So this loss may attenuate our signal, and in the end, in our receiver side, the signal may be attenuated too low to be received, and then that is not ideal, and we do not want it. So we need to make sure in our the signal source is strong enough for us, so that even though we are having some power loss during the propagation, it's still being received by us in the end. And after that, we have the ELT system, and we need to know what it is. And this is for chapter 6 about the airborne communication. And after that, we'll talk about the chapter 7 is related to the terrestrial radio navigation and landing aids. So this part is actually like a lot of things is discussed and talked in this chapter. And for example, we talk about NDB using ADF. You need to know how it works. So the basic principle is that it uses this kind of antenna, and you are going to measure the difference on different sections, then you know the directions. So that's the basic idea. You need to remember how the principle of how it works. And for the VOR and the VOR, that one is also very important. And this one, you need to know how it works. And the principle, for example, if you remember, we have two sources. One is the directional, the other one is omnidirectional, and how to base on this property to measure the heading and the relative, let's say the bearing of our aircraft. That is very important. And after that, you need to know why we're going to invent the DVOR and how it's going to be substitute our VOR system and the improvement of doing so. And also, we have our VOR indicator. And after that, we will also talk about DME. So VOR is giving us the bearing, which is the angle of our aircraft relative to a station. But we still need the distance, right, to know the location. So we need the DME, in which you need to understand the principle of DME, how it's going to measure our distance. For example, like this. So for DME, it's going to be propagating a signal from our aircraft like this, and then being received by the station and propagating back. And we have inside of this signal, we have this kind of codes, and then we're going to be receiving. So the details you can find in the recording of the lecture. So of course, something you need to remember is that inside of this DME, I introduced like 5. Like this number, I think this number is not correct. Anyway, you can find the direct number of. Anyway. So after that, we will have the iOS. iOS is related to landing, if you remember of this figure. So you know that we have a different instrument to help us landing. For example, you have the localizer. The localizer helps you to know the heading, whether it is correct, whether your approach angle is correct. And then in the horizontal direction, and then you have the guide slope. So the guide slope is related to the, let's say, how it's going to be approached to our, and for landing, whether it is okay. And also you control the attitude of the aircraft. And yeah, but besides that, you also need other instruments like the marker beacons for you to guide your landing. And most important is that you need to know how to read the indicator. For example, this instrument, you need to know which line is from guide slope, which line is from the localizer, and then you need to know the correct movement for it. For example, you know, for this one, let's say, what you need to know is that, for example, I'm giving you this kind of indicator. You need to know which one this one is related to that, and you know the current aircraft, what the correct action it needs to be done by our pilot. For example, for this one, if you're having this indication, you need to fly right, and also it's going down. So the basic idea is that if this one, the deviation is on the, let's say, on the right-hand side, so you need to fly right to follow the same direction. If it is lower, it means it needs to be going down, following the same direction. For the opposite one, it's also the same. You need to understand the correct movement so that your indicator will be recovered into the sensor. And then you can have the flights to have the landing correctly. So this one you also practice during your flight simulation. I believe many of you have no problem for this one. Others. So after that, we also have HSI is the same as the indicators. And also we have the radar altimeters. You need to know how it helps us for the landing. And that's for the chapter 7. And after that, we'll talk about the surveillance systems. So for the surveillance systems, we basically talk about things that related to radar. So for the radar system, it's very important. You need to know the working principle. And most important is that we talk about the maximum unambiguous range. This one is it also involves some calculation of this, and you need to understand how to calculate this maximum and unambiguous range. And for example, you need to know the reason of this unambiguous range. It is because that you have the reflections, then you need to have a certain range so that it is not going to have misunderstanding of the early arrival of the later arrival of the reflections. And this range, you need to have know how to use equations to calculate it. And also the affecting factors and the distortions of our radar systems. And yeah, for example, our aircraft have a certain size, and also our radar is going to be rotated so that we have some kind of distortions. And then in our avionics systems, we have the primary radar and the SSR, the secondary one. So we have these two. So you need to know the principle of both these two and also the components. For example, like the SSR, we need to have the ground station and also our aircraft. And inside of our aircraft, we also need the corresponding facilities, instruments to make this happen, because we need to have a reply to the ground station. And we have interrogations and different modes, and you to roughly know how many modes it has and which mode is corresponding to which mode. And also most important is the details related to mode A, because we spend a lot of time to talk about mode A. And I believe that if you fully understand the reply of mode A and how mode A what mode A describes and different codes and how it codes the principle of the codings in the mode A, you can use this knowledge to understand other modes. That's very straightforward. For example, like different so here let me supplement some of the principles. So the radar one is going to have reflections. You receive the reflection, then you got the range, and this one is related to the unambiguous maximum ambiguous range, because that the later one is shorter, and you do not know that this shorter one is coming from this one or the very early one. And for this figure, we know that we have the distortions, and these boxes is related to the distortions and some limitations of our radar system. And we have the primary one and secondary one. And the working principle is very different, because the primary one is based on the reflections, and the secondary one is that you need to have some kind of communication, so that it is kind of like active one, so that you need to have a reply, receive a reply from them. And looking like this. And for the coding system, you need to know how to read those codes. For example, different boxes looking like this. If you have a wave looking like this, you need to know the exact number, what it indicates. And after that, we talk about something related to, besides, we also need to understand the limitations of PSR and SSR. For example, the pros and cons of these two systems, why these two need to be combined together. And after that, we also very rough discuss the needs of the TCAS and ADS-B, and I leave you to some of the groups to have good case study. So we will not have a very detailed understanding of TCAS and ADS-B, but you need to know the needs, why we are going to require these two systems, like some of the limitations from the previous avionics systems can be solved by having TCAS and ADS-B. And of course, these two will be related to the very first lecture, let's say, the futures of next gen. So of course, it will be related to some of the topics in here, and you need to remember something that related to that. And for the chapter 9, is more related to the avionics system integration. So for this one, we talk about the federal architecture related to the principle of AIR-IN 429. So this one is, we spend a lot of time to actually read the number of it, the message of it. you need to remember that the architecture of this, the structure of the message looking like this, and different sections, different parts of this message has a certain meaning. For example, BCD is representing to some kind of meaning, and BNR is another kind of method to read this message. And you need to know different boxes is indicating some of the information. For example, the first one to the 8th is related to the label, it's a description of this message. And inside of here is related to some of the numbers that is related to the parameters, the values of the information it carries. And also we have checking value, for example, the priority check. This is to guarantee the message is correct. You need to know how to do this check. And if you this one you can directly, I think it's in tutorial 2. I will have a very detailed example of how to read this message. And this one is very fundamental. And after that, we talk about some like principles, like the principles of it, and then we have the comparisons between 4 to 9 and 6 to 9. So this one is the architecture of the federal architecture. So looking like this. So if you're going to compare with the integrated modular avionic architecture, it's looking like this. So you need to know how to distinguish these two kinds of architectures of our avionics supporting systems and the pros and cons between these two. So in the end, after you reviewing this lecture, what you need to understand is like the development of our avionics system integrations. Like in the beginning, it's a very distributed analog system, and later you have some distributions will be like it's going to be, let's say the distributed system is going to become digital because digital is much better than the analog in our case. And after that, we will have the federal design and looking like this. And after that, we have the very integrated modular. This one is more compact and also more, let's say, is centralized and easy for us for maintenance and also to control the system and the benefits. You need to know that. And that's for the chapter 9. And so that's the main idea of the whole 9 chapters for us. So they have some of the things you need to remember. Parameters and algorithm, like the principles you need to understanding. So actually a lot of parts is to understanding the principles. So during your examination, you'll find out a lot of questions. It's going to ask you the principles of kind of like one system or another indicators. So that's related to principles. You need to write some of the explanations by yourself. So please, because we actually have a lot of things, not so lots of, but still, if you spend too much time on writing a very comprehensive answers, you will spend too much time that you do not have enough time to do so. So please try to make a concise word on answering those questions. And for example, if I tell you to how it works, the principle, just to mention the very key principles, you think that is concise enough to show the main idea of how it works. Do not write a whole essay, like 1 page for one question. That's too much. Then you will not have enough time to do so. Yeah, and try to manage your time for doing the question, because the question is like a lot of like asking you the principles. If you answer it with too long time for one single question, that's not worth it. So try to firstly go through with the whole examining paper and all the questions. After you go through all the questions, you have the main idea of that, how many time you will spend on each question, and try to manage your time. And let me see. Okay, so that's for it. That's mostly for it. So let me show you some of the things I am going to be available in your exam paper. So in your examination paper, for those calculations, I will give you this kind of equations. And if you remember that this equations is not giving you that kind of like those when you're calculating those seven parameters, that is not related to those, not include those numbers. For example, we have one kind of the equation that this kind of things is also input with the exact number on it. But what available in our examination, we do not have exact number on these equations. But I will give a table of all the numbers you will have. Then in the examination, what you need to do is that you need to know which parameter is the parameter you need to calculate for that question. And the other parameters, you need to know how to find the value of those parameters and the meaning of those parameters. For example, like T0, you need to know what T0 is and how to find T0. For example, in this table, yeah, T0 is looking like this. And for example, some of the question may not use T0, may use T others, or let's say other things, but that must be already been taught in our lecture. Yeah. So you need to know that you need to put the correct number in it. Yes. And of course, in our table, I will also input a lot of other things that may confuse you. So do not, so try to not to use the wrong numbers to input the equation, something like that. And yeah, but for the vertical speed, I will give you looking like this because deviation is related to the differential. Is much more hard for you to derive. And yeah, that's for the equations. I will give you like this. And this is the table that you may refer on to find the correct number. And also this equation is related to the change. And most important is for the attitude calculation, because this one is related to the parameters, the definitions of different parameters. You need to know what you need to remember is that what these symbols is talking about. For example, like phi is related to what, theta is related to what, yeah, and this one. And this equation I give you to you. P, Q, R, what are they related to? It's rho, P, Q, right? And then all the equations are be given in here. Then what you need is that you base on the correct equation to derive the term that the parameters you need for the questions. Yeah, you have a lot of equations. And some of the constants I will also be given for you because those constants are not necessary to remember. So that's the thing you have during your test, a lot of like 4 pages for it. Yeah, that's for it. Okay, so that's for it. So you need to understand different variables, what the meaning it looks like, how to find the correct value. So I think that's okay. Yeah, I think that's okay. So again, I need to remind you, don't write too much on each question. Yeah, because I'm also like very hard to read a very long essay, and also it also spends you really a lot of time. Okay, so that's all it. And let's talk about other arrangements. So for the assignment 1 and assignment 2, I will because assignment 2 is just collective on you guys, and we are still under the marking process. So after we've done the marking and the grading, and then I will ask our TA to return to you the assignment 1 and assignment 2 in e-copy, and so that you can go back and see which part you may do a wrong answer on the calculations, and you can try to correct your calculations, and then you use the correct way in your examination. So I will try to do it. I will make it before your examination with some kind of available times for you to double check. And do we have other things? Yeah. There also has also other things. In this for this subject, it actually involves a lot of different kinds of knowledge. So if you do find some of the knowledge I I did not explain it to very well, or you need to understand more in it, you are feel free to ask me. And also some of the assignments, if you are not sure whether it is correct, or after you collect your feedbacks of the assignment, the gradings, and you find out you don't know how to derive it,